As weird as it may sound, not all equations work. Most of the time, we have one solution to an equation, and that's when we solve it and we get something like x equals 3, y equals 0, right? We get a variable equal to a number, and that's our one solution scenario. But there are other times where we may solve a problem and we may get something that looks like this. X equals x, 12 equals 12, -3 equals -3. That is a situation where we have infinite solutions because no matter what, -3 is always going to equal -3. So if something's always true, it's going to be true for every value of x. Or we can end up with a situation where we get something that is never true, something that doesn't make sense. And something that doesn't make sense is going to have no solutions because, well, there's no way to make 12 equal 2. So when we look at the equations for these, with a one solution equation, we'll have different coefficients. So the number in front of the variable will be different, right? And then the constants may or may not be the same. But from here, I can see that I can solve this and actually get an answer. Now, with infinite solutions, basically the reason they're infinite solution is because both equations are the same. So no matter what value we put in for n, it is always going to be true. So that's why we get infinite solutions. And then with no solutions, we get the same coefficient. So our multiplier is going to be the same, but then we have different numbers. So we can't take a number times 3 and add 5 and get the same things as times 3 and add 9. That'll never work. And that's how we get no solutions. As far as what this looks like in a situation, this always has to do with two things being equal, trying to find out when two things are equal. So in this first situation, right, Terrell's running faster, but he's starting behind. So we know that there is a way for him to catch up, and that's why these variables are the same. So 3 miles an hour, we want to know when that 3 mile an hour is going to be equal to 4 miles an hour, but being 2 miles behind. All right. In the second situation, where we're looking at Kia's allowance is $10 per week, Kamaya's allowance is $5 per week from her mom and $5 per week from her grandfather. When will they have the same amount? So again, we're looking for when these values are equal. So 10x is what Kia's making, and then Kamaya's getting 5x plus 5x. But when we combine like terms, we see that we have two equations that are exactly the same. And so this is infinite solutions because every week they'll have the same amount. Now in this final situation, Lyric is walking 4 steps per second. Kai is also walking 4 steps per second, but he is 9 steps ahead of Lyric. So 4 steps per second, so 4 times s, equals 4 times s, but him being 9 steps ahead. And when we solve this, we get 0 equals 9, which makes sense because if they're walking at the same speed, but they are at different starting positions, they will never meet. So Kai will never catch Lyric in this situation. And so when we're solving equations, that's what we're looking for. It's like, yes, most of the time we'll get one solution, but let's take a look at this one. So 3, I distribute first. So I get 6x plus 12 equals, and then I distribute that, equals 6x plus 12. Now, again, from here, I can see that these equations are exactly the same, but I can keep going with my steps, minus 6x, minus 6x, and I see that 12 equals 12. Well, again, this is something that is always true, so that is infinite solutions. So any value I plug in for x will work in that situation. All right, and then in this situation, all right, so there's nothing to distribute, but I'm going to go ahead and combine my like terms. I have an 8n plus a 6n, and that's going to give me 14n minus 5 equals 2n plus 1. Okay, move my variables to one side. Okay, and I can see here, like even from now, I can see that I'm going to get a solution because I'm not getting rid of my variables. 12n equals 6, divide by 12, divide by 12, and n is going to equal, if I simplify that, 1/2. So that would be a 1 solution. Okay, now going back to this problem, if this were minus 6n, when I combine those like terms, I would end up with 2n minus 5 equals 2n plus 1. Now in this case, again, if I subtract that 2n from both sides, I get negative 5 equals 1. And that is not possible. So this is not equal and therefore is no solutions.